Hello, everyone. We are honored to be presenting at this year's Informs virtual annual meeting on estimating the effectiveness of identifying human trafficking via data envelopment analysis. This research is a collaboration between Northeastern University, Worcester Polytechnic Institute, and a non-governmental organization called Love Justice International. Now, to provide you with some faces to the voices you'll be hearing today, my name is Alex Bender, and I'm a recent industrial engineering graduate from Northeastern University's College of Engineering.
Hi everyone, my name is Malak. I recently graduated from WPI with an industrial engineering degree.
So the overall vision of our project was rooted in a desire to help organizations, more specifically resource-constrained non-governmental organizations, recognize and respond to human trafficking using operations research methods. But before we really delve into our research, it's important to note some foundational concepts and some background concepts. So what even is human trafficking? Human trafficking is typically described as some form of forced or fraudulent exploitation of a person. This can be in the form of sex trafficking or labor trafficking. The key takeaway about human trafficking is it's an incredibly complex and nuanced problem to solve. So any operations research models that are used to address human trafficking need to capture these nuances as well. It's also important to note common mitigation technique for human trafficking that's used. It's called transit monitoring. What this consists of is monitoring typical transit hubs such as train or bus stations to observe any suspicious activity. This effort is typically led by NGOs, but it does not replace border security. They still have agency in these situations. These NGOs train personnel to understand and identify the nuances and signs of human trafficking, and then the personnel themselves attempt to intercept, intervene, and prevent trafficking. The NGOs also provide resources to people crossing the border that may find themselves in a trafficking situation. In general, transit monitoring is a strategy of mitigating human trafficking at one of its most common locations, transit hubs. You can see in this map of Nepal some examples of transit hubs highlighted. So Nepal's entire southern border is with India, and that's what we focused on for this research. The border is about 1,100 miles long, and it's an open border, which means people can more or less move freely. And as you can see highlighted, most of the transit hubs here that we worked with are on or near a border.
So a little bit about Love Justice International. We will refer to it as LJI going forward. It's a non-governmental organization that combats human trafficking through transit monitoring methods. They focus on preventing human trafficking by placing trained personnel at key transit points to identify people who exhibit signs of potentially being trafficked. So they operate in about 15 countries, but we focused on the Nepal-India border, and they actually create and maintain a data set from that border, and we have data from 2011 all the way to 2018. And this data is in the form of IRFs and VIFs. This data is actually collected by the people working on the grounds from their 25 to 30 stations, and that variance is due to certain stations opening and closing. So a little bit about IRF and VIF forms, our main source of data. Due to confidentiality purposes, we actually can't show the forms, but we can explain what the forms contain and also the process that goes along with filling out these forms. So they capture both potential labor and sex trafficking transit activity, and the data includes detailed demographic information about both the victim and the trafficker, and also rich information regarding the trafficking supply networks. So LJI actually created a point-based system called red flags on the IRF to help guide staff in determining if a person is at risk of being trafficked. And this point system assigns large numeric values to questions more indicative of risk. When an IRF exceeds this predetermined red flag threshold, an interception of the individual is attempted, and a VIF is administered for each person in the group. When deemed necessary, the trained staff actually refer the victims and the perpetrator to local authorities for further investigation and services. So while we actually had years worth of data in this form of IRFs and VIFs, we could not do the analysis without cleaning up this data. So our process actually included linking the IRFs to the VIFs. And just to give a little bit of context, so each person in a group doesn't actually have an IRF. So an IRF is filled out for an entire group, and then a VIF is filled out for each person in the group. So we actually had to link the IRFs to their corresponding VIFs for each person in the group. And organizing the data, we had to organize it in a manner to reduce redundancies, filling in and removing missing fields, and correcting any inconsistencies in these files.
So now that you have more of an understanding of the foundation of this research, we want you to understand our refined research objective. LJI was hoping to improve its operations and was interested in identifying best practices and transferring learnings between its stations. At the core, by improving operations, LJI will be helping more people and preventing more people from being trafficked. So that's where we come in. We wanted to explore with this research how we can help LJI improve its effectiveness and efficiency in operating their stations using OR methods. Data envelopment analysis was our answer. With this analysis method, we were able to quantitatively assess and benchmark LJI station performance and ultimately support LJI in their endeavors to improve operations.
So a little bit about DEA. It's a linear programming techniques for assessing relative efficiencies of decision-making units, what we call DMUs, that consume multiple inputs to produce multiple outputs. And it can be used to identify and objectively benchmark efficient units, such as border crossing stations in our context. And efficiency is actually based upon consuming inputs to produce outputs. So our main goal for using DEA was to quantify the relative efficiencies of human trafficking interception at various transit monitoring stations. And the purpose was first to identify which stations are considered efficient and how the level of efficiency ranks among those stations. And these results could then be used to identify potential methods of improving human trafficking transit monitoring tactics. So through discussions with LJI and analyses of available data, we identified key inputs and outputs for our DEA modeling. So we considered 4 inputs for each station: station duration, number of staff, test scores, and flow. The station duration is the length of time that LJI has operated a station. The number of staff members represents the average number of LJI personnel employed by each station each quarter. Test scores represent the average staff performance on the border knowledge exam, a mandatory exam which each person takes before they are employed. The flow is the estimated magnitude of total travelers through a station, which is derived from several factors such as the distance from the Indian border, number of airports, bus or train stations, number of major highways, and population density. And based on those values, a value of 1, 2, or 3 was assigned to each station, obviously 1 being the lowest flow and 3 being the highest. For our outputs, we also considered 4 outputs: number of IRFs, number of VIFs that were filled out, and their completion. So for completion, to give a little bit about that, as a group of people are crossing, the VIFs are completed for each person in the group. They are asked questions, and based on those questions, the forms are completed. If the answer was filled out, it was given a value of 1. If the question was not filled out and left blank, it was given a value of 0. So the completeness is measured by the number of completed question over the total number of questions. And because there's 3 people going together, the score for a VIF can be interpreted in multiple ways. Do you consider the score of each form in the group? Do you consider it as an average? Do you consider the minimum score? Do you consider the maximum? So we created 5 models to kind of explore the possibilities with these different interpretations. And after consultation with LJI, we went ahead with the model where the VIF completeness is actually a sum of the completeness for all the members in the group, because this was this was inclusive of all the completeness of the forms. And another DEA assumption we considered is about having homogeneous stations. After all, DEA aims to view stations in their best light. So it's only fair to compare DMUs that operate under relatively similar environments. So for our context, the criteria we used for uniformity are the distance from the Indian border, population density, quality of data, and actually having a station manager. So stations that shared similar criteria were grouped, and that was stations that were within 5 miles from the Indian border, at least 2 bus or train stations, at least 100,000 people per square kilometer, And we did that because we assumed that these represented locations that had a heavy flow of people and thereby an increased likelihood of intercepting trafficking activity. And the stations that were chosen were also, they needed to not have any missing data, and they needed to actually have a station manager. And out of the 18 stations we had data for, a total of 6 met these standards. So those were the only ones we used in our analyses. And finally, we wanted to ensure that there was a sufficient number of DMUs to conduct a stable DEA analysis. So each of the 6 stations was expanded to 8 calendar quarters of data, and therefore we had 48 station quarter DMUs. And I know that we mentioned that we had 7 years of data, but we found that it was only the last 2 years that contained no missing data for the stations that qualified. So this visual shows the 6 stations that qualified to be in our analysis to give you guys a geographical perspective.
So now let's get into some specific results of our DEA model. In general, DEA enabled us to get a more detailed understanding of how the stations compare to one another. In this graph, you can see on the y-axis are the station names, and on the x-axis are the different periods of times, or quarters. You can see that some stations, such as Nepal-India, are always efficient, whereas other stations change by quarters. This is a good indication of the variety in station performances. However, this graph just shows what stations are inefficient and inefficient. We don't yet know which stations are the most efficient or how much the efficiencies changed among the stations. This graph, on the other hand, shows specific ranking of each station relative to one another. This is showing the average cross-efficiency score over the 8 quarters. So in aggregate, you can see which stations were overall the most efficient at producing outputs. This was used as a tactical guide to show LGI which of their stations they should treat as models and which can use improvement. This directly supported their desire to share best practices between stations. This slope graph tells a slightly more detailed story. The cross-efficiency ranking of each station is shown for every quarter. As you can see, some stations are consistently ranked at the top, some are consistently near the bottom, and some are quite variable. This both gives us more information than just inefficient versus efficient, and it supports LJI's efforts by directing them to specific points in time. This analysis helped them to match station performance to specific points in time and distinguish between stations at those points in time. And finally, this box plot graph tells a similar story, but more succinctly outlines the variability between the stations' performances and efficiency. The biggest takeaway from this graph is there's a lot of variability in some stations, whereas others are more dialed in and more efficient. This directly helps LJI to focus their attention on highly variable, less efficient stations.
So our recommendations. As we mentioned earlier, our model is an output-oriented model, which means we focused on maximizing the outputs in order to increase efficiency. So the first 3 stations needed to increase the completion of their forms, meaning that they needed to increase the quality of their recording process, as a lot of the questions were left blank. Meanwhile, Kakarvida, Lahan, and Bhadrapur did not collect many forms. Therefore, they need to increase the number of forms that they collect. However, it's very important to note that within the context of intercepting potential survivors of human trafficking, it can, at a surface level, be problematic to simply just assume that increasing the collection of forms is going to increase productivity. We need to ensure that there is still quality. Therefore, the quality of these forms and the interceptions being made must remain paramount. And then moving on to the last 2 stations, Nepal-Ganj and Bhairawa, they actually had efficient output values, therefore they just need to maintain their current performance.
So there are a few main takeaways of this presentation as a whole that we'd like you to understand. First, combating human trafficking with OR is possible, and using OR methods to help resource-constrained organizations is an impactful thing we can do as engineers. It is possible to help people, even if it's just a little, with mathematical models. Second, we presented a DEA model that evaluates the efficiency of cross-border transit monitoring stations. To the best of our knowledge, it is the first use of DEA in the NGO and human trafficking space, and it proved to be effective at reaching our research objective. Lastly, our findings helped LJI with specific recommendations and direction to improve their own operations. After all, LJI is the organization that is out on the Nepal-India border trying to reduce human trafficking, so we are proud to know that they found value in our analysis. Thank you so much for your attention today. We hope you enjoyed our presentation. If you have any questions for myself or Malak, please don't hesitate to reach out to our emails listed. Our preprint citation can also be found at the bottom of this slide. Thank you so much.
Thank you.